Hi everyone, this is section 3.6, which is on rational functions. This first video I'm going to just do a walkthrough of the textbook and kind of make some, point some things out and go through a couple of the theorems and definitions that are in the text instead of writing them all down on paper in a video form. I thought I'd walk through the text. You do have access to the ebook, so make sure that when you're going through those, I want you to make sure to point those pieces out as well. I will do other videos, of course, to go through some examples. These problems are a little bit time-consuming, as like the 3-5 was and 3-4, finding the zeros of polynomials, because we're going to be doing similar topics. First of all, kind of have to understand what in the world a rational function is. Kind of thinking of rational number. Rational means fraction or can be put into a fraction. So when we're talking about a rational function, we're going to look at a function that is a polynomial over a polynomial. So P and Q are polynomials, and we've spent a lot of time in the previous sections talking about polynomials. We're also going to assume for now that they have no common factors. In other words, there isn't an x minus 3 that factored out of the numerator and an x minus 3 factoring out of the denominator. I will talk about those in another video about what happens when that is there and what that means. First of all, we're going to talk about asymptotes. Rational functions a lot of times will have asymptotes, vertical asymptotes and horizontal asymptotes. So we're going to look at a very simple function to start with, 1 over x. And then just looking at some values, so 0.01, and getting some function values. So as this gets smaller, so look at here, negative 0.1, negative 0.01, negative 0.0001, the function values start to get really, really large. And if you think about it, if you divide by something really, really tiny, it's going to get really, really large on you. Notice we're on the negative side here. These numbers are getting very, very large, but negative. So we like to say that this is approaching 0, so getting really small or close to 0. And the little minus sign tells us what side of the number line we are approaching from. So picture the number line, and we're coming in from the negative side or the left side. As that happens, our numbers are getting larger, getting bigger and bigger, hence going towards infinity, but negative, so they're getting towards negative infinity. If we looked at the other side, approaching 0 from the positive side, so from the right side, those numbers also get large, and they're going towards infinity. So the little plus tells us we're coming in from the right, the little minus says we're coming in from the left. Again, think of the number line. We do look at a picture of 1 over x, and it does kind of look like this. So this is our 1 over x. And notice that f of x did go towards 0 or infinity as x went to 0 on the right. As x's got really, really large, we were dividing by a really large number, our function went towards 0. So we do also have a horizontal asymptote. So we have a vertical asymptote and a horizontal asymptote. If we have vertical asymptotes, a lot of times we will denote them with dotted lines. Same with horizontal, we'll denote them with dotted lines. We don't need to do that here because of the axes. So just again, some notation. And I feel like I'm going a little fast, but I'm just kind of highlighting some things in the text itself. So going to A from the left, coming to A from the right, so the little plus or minus, does not necessarily mean positives and negative numbers. It's telling you what side of A you are on. This is saying we're going towards negative infinity, going towards positive infinity. So our definitions of vertical and horizontal asymptotes. So first of all, the vertical. And notice we looked at a dotted line. So here we're saying that our function, our y values, are going towards infinity as x goes towards A from the right. So if this was the number 2, we'd be at like 2.01, 2.001, 2.00001, and our values would be getting larger and larger and larger. So our y values would be getting increasingly large or heading off towards infinity. If we're coming in from the other side of 2, for example, so at 1.9, 1.99, 1.9999999, that is on the left side of 2, hence coming into A from the left, and our values are going towards infinity. So we can have things that go to infinity on both sides, so going up on both sides. We can have things going towards negative infinity on both sides. So here's pictures from the right and from the left. So they're going, or we could have them split like they did in the 1 over x picture before. Here we had one side going to a positive, one side going to a negative. And as I'm working through examples, I will kind of indicate how we can tell which is which. A horizontal asymptote is what happens as x goes towards the ends. So as x goes towards positive infinity or it goes towards negative infinity. What is the function getting close to, if anything? Not all functions have horizontal or vertical asymptotes, but we will find out when they do and when they don't. So a horizontal asymptote means that it's going to get close to that value as your function goes either towards infinity or negative infinity. The one thing that we will have if we have a rational function is we will only have one horizontal asymptote, and that function will approach it from both sides. For a polynomial over a polynomial to split, it can't do that. You can't have it going to one value on the positives and a different value on the negatives. So that's one nice thing about polynomials or rational functions, polynomial over polynomial, is our horizontal asymptote. We only have one. There are some really strange functions out there, and if you had a piecewise function, all bets are off. The next thing they go through is a couple examples on just transforming 1 over x, and I will do those in another example, another video, because I want to talk about all the pieces first of all. So, finding those asymptotes. First of all, the vertical asymptotes are basically the values where that a is a 0 of the denominator. So if we're looking at the bottom, if we have our 0, so we're going to be trying to factor this place here, and that's where all of our vertical asymptotes are going to be, provided, again, these guys do not have any common factors. I will go through an example when they do have a common factor and talk about that. So we have a polynomial over a polynomial. So for vertical asymptotes, those are the zeros of the denominator. We're also going to be finding possible horizontal asymptotes. And to find out if we have a horizontal asymptote, what we are going to do is compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is smaller than the degree of the denominator, so n is smaller than m, we will have a horizontal asymptote at y equals 0, similar to 1 over x. Degree of the numerator there is 0, degree of the denominator is 1. We saw it going towards 0 on both sides. If those two things are the same, you're going to look at those leading coefficients, and that ratio will be your horizontal asymptote. So if you have a third degree over a third degree, the ratio of those leading coefficients will be your asymptote. If the numerator is larger than the denominator, we do not have a horizontal asymptote. We could have an oblique or slant asymptote or some sort of curved asymptote. And I will go through an example of that also in a different video. So to graph these polynomials, we have some steps that we're going to go through. And our steps are going to be as follows. And again, in different video, I will go through some examples. So what we're going to do, here's going to be our steps, is we're going to factor the numerator and the denominator. Okay? Once we have it factored, we're going to reduce it down if at all possible, and then go to the next steps. If we do reduce it down, we're going to make a note that we did do so. We will find any intercepts for our x-intercepts and our y-intercepts. The x-intercepts are going to be coming from the zeros of the numerator, because if you set your fraction equal to 0 and you were to multiply by that denominator, it would disappear and it would come, the zeros would come from the zeros of your numerator. And I'll explain this as we go through examples as well. We will also find the y-intercept. And we know how to find a y-intercept by taking and letting x equal 0 and finding what the y would be. We'll find vertical asymptotes. Again, they're the zeros of the denominator. We're going to see if they go to positive infinity and negative infinity from both sides. And the way we're going to do that is use some sort of test values. So we'll pick in some points. We're also going to do our test for a horizontal asymptote and determine if we're going to have going to a value or not, or if we have an oblique or slant asymptote. And then once we get all that, we're going to do a very, very rough sketch. So that's kind of where we're headed, and this is the part that's going to take us a long time, because we're going to have to do some of these things. Factoring in this section, we're going to make sure that things are factorable nicely. It could be a very complicated problem if we put something that we had to first of all find all the zeros, like we did in 3-4 and 3-5, into this section. In this section, we try to either have them factored for you already so we can just apply this next step, or something that is easily factorable. So kind of hoping that that all makes sense. All right, I'm going to stop this video here. So let me quick check and double check, and otherwise I'll be going through some of these things as examples. So yeah, I am going to stop the video here, and in the next video we will go through some examples. Hi everyone, welcome back to 3.6. In this video we're going to go through 2 examples, and then we'll do, we're going to do quite a few examples in this section, but we're going to start with this example, and then I'll do one more on this video, and then I'll switch to another video to go through yet more. So first of all, we're going to look at 2 over x minus 3. Now this one is very similar to this function. Okay, and this function we did look at in the first video. It was the one that looked like this, roughly speaking. And you could plot a few points in there to get some accurate values, like putting 1 in there, sorry about that, 1, 1, and 1, negative 1. You could put 2 in there, and you'd have 2, 1/2, 3, 1/3, and so on and so forth. So we could see those. But we're going to compare this one to this guy. And now what you can kind of see is we do, instead of having an x, we have an x minus 3. which means this function has been shifted to the right 3 units because I put in this guy inside that function. So kind of remembering all the rules to shifting. Now this 2 here is kind of like, well, how in the world did we get a 2? So I'm going to rewrite this to make it a little bit more apparent. And we'll notice that we're taking 2 times that function. So this is going to stretch our values. So we're going to be going to the right 3 units and stretched vertically. Stretched vertically. Sorry about that. So rough picture, here's our original axes. Our asymptote here is going to be shifting over 1, 2, 3. And this point here, which was at 1, 1, first of all, it's moved over, but instead of going to 1, we're going to be up at 2. So here, instead of being at 1, we will be up at 2. And at that 2, which was at a half, will now be at 1. So it's going to go up a little faster and then come down. Similarly here, this would have been at this value 1, but it got stretched and stretched, so we can kind of draw in rough pictures. We could find that y-intercept, so we could actually label it if we wanted to. If we let x equal 0, if I let x equal 0, I get that y is equal to 2 over a negative 3, or negative 2/3. So we could kind of put a dot in there, which would be actually at negative 2/3, if I'd wanted to make more detailed axes. Okay, let's look at one more. And the one I want to look at is this guy. We'll call it S. And we have 3x plus 5 over x plus 2. And now that one is like, well, wait a minute here. How in the world? And I'm going to tell you it is a shifting or a translation of this guy. But it doesn't look like it. I mean, I can see the 2, the x plus 2 in there. But when there's this x up on top, there's no x in the numerator of the original function. So what I'm going to do is I'm going to do some long division. And I'm going to come back to this one again in another video. We'll start with this one again in the next video. Kind of not thinking along the lines of transitions, and we'll see how we would walk through it just as it sits. But I'm going to go through this one first of all as a translation. Honestly, I would not have seen a translation unless someone told me. But I'm going to do my long division. So I'm going to take this 3x plus 5, and I'm going to divide it by x plus 2. So again, practicing our long division. To get x to be 3x, we need to multiply it by 3. Again, we're going to multiply both pieces, so 3x plus 6, and we subtract. So this gives me a minus 1. So this is actually equal to 3 plus a negative 1 over x plus 2. So now we can maybe start to see that translation. The x plus 2 is going to shift it to the right 2 units. This minus 1 is taking our function and multiplying it by that negative 1. So that is going to flip it along the x-axis. So flip it upside down. And then the plus 3 is going to go up 3 units. All right. Let's kind of think of what we're doing here. So I'm taking this guy. We're going to go to the right 2. So 1, 2, and that's where that asymptote is going to be. And then we're going to take our value here, so this guy here, and we're going to flip it. So it would start about there and then the half, and the third, and so forth. Okay, I'm just going to put little X's. This one on this side would be flipped up here, and then the half. But then we need to move them up 3 units. So this asymptote here is going to go up 3 units as well. So we're going to have an asymptote that's going to look like that. And this point is going to be here, and then we'll have that half. And it would look something, that's very rough. So roughly like this. And again, I would not have seen that this was a transformation had I not been told, hey, this is a transformation of your 1 over x. So I went and looked for the 1 over x. I'm going to stop this video here. Again, I'm liking to keep them nice and short. And I'm going to do the next video with this guy as it sits, going through some other processes, learning how we did these guys, these problems in general, if you're just going to jump right into them. So we'll look at this one again in the next video.